Collecting data. Other indirect emissions. Collecting data for Scope 3 emissions is more challenging because energy records aren't usually available to the entity generating the report. For instance, when calculating air travel, it is unlikely that the airline would tell you exactly how much fuel was consumed on your trip and what your share of that was. Though, with the steady increase of ever richer information these days, and air travel soon to be included in Europe's emissions trading scheme, it might just show up on your ticket one day. To help quantify air travel, a number of useful online calculators have recently become available, with the likely standard bearer the one maintained by the International Civil Aviation Organization, ICAO. When confronted with a large number of air activities, however, it is not time effective to manually calculate each trip, and a different strategy needs to be employed. One way is to divide trips into short, medium, and long, and assign a value to each category. Another approach is to work with IT staff and configure the expensing procedure in, say, PeopleSoft, in such a way that three-letter IATA codes must be entered along with the dates and amount. That way, a report can be run that pushes out the departure and arrival points for the entire organization in one go. The IT team can then run that table against a simple Great Circle navigation formula, and voila, here are the total miles or kilometers flown. For ground travel, it may be that employees don't really know how much energy was consumed on business trips, or in their commute to and from work. And for upstream and downstream emissions, say the shipment of products, it is unlikely that suppliers can provide fuel use records for just your shipments because that is not how they track their own fuel use. In light of these circumstances, many organizations have successfully used survey instruments to help estimate their Scope 3 emissions. Surveys can be an effective way to capture Scope 3 emissions of staff business travel in cars, trains, and planes. Though some accuracy is lost this way, most reporting programs allow you to footnote data submissions and ascribe a level of confidence to each data set. Simply use that to explain the survey approach, the results, and maybe address some of its shortcomings. Submit that along with your emissions data. In the case of car travel, the activity data required for calculating emissions is total fuel use in gallons or liters, type of fuel, such as gasoline, diesel, E85, natural gas, the number of occupants typically in the vehicle, and if travelers include non-company staff, that should be recorded in order to properly calculate the share of emissions attributable to the company. There are two general ways to obtain fuel data. When available, the best way is to use receipts. When not available, fuel use can be estimated. You would need total distance traveled, average fuel efficiency of the vehicle, and fuel type used by the vehicle. Here we have outlined a survey that was used to estimate greenhouse gas emissions from employee commutes at a large organization. With several thousand employees traveling to and from work each day, the practical way to obtain the data was by administering a survey. There are many online tools such as SurveyMonkey that can be used to broadcast surveys and aggregate the data efficiently. In this case, the information needed was the number of employees, their mode of transport, whether they carpooled, the approximate miles per trip, the number of trips per day, and the number of days worked per year. As you can see, some of this data could also be collected from the organization's human resource department. But in this case, the information was collected and the accounting initiative was communicated to the organization by administering a survey to the workforce. Assembling emission factors. Once all the activity data has been gathered, the next step is determining the appropriate emission factors. Emission factors are published by a wide range of state and national agencies, as well as intergovernmental agencies such as the IEA and IPCC. Emission factors exist in a large number of formats. They can express average emissions for fuels, industrial processes, agricultural practices, animal types, waste streams, average leakage rate of cooling systems, maritime shipping, air transport, among many others. Depending on the purpose of the dataset, emission factors can be benchmarked against a single event or a year's worth of events, an industry-wide average, a national average, against a certain population number, gross domestic product, or the weight of materials produced. For the purpose of this module, however, we will keep it simple and focus on factors common to basic greenhouse gas inventory preparation. Emission factors for fossil fuels generally remain constant over time, but emission factors for electricity consumption, as well as those for travel by bus, train, and air, are frequently updated, so it is important to use the most recent emission factor available. And when emission factors are not available in the same units as the activity data you are collecting, scaling them up or down is okay. For example, in the US, the EPA provides an emission factor for the combustion of natural gas at 0.12 pounds per cubic foot. But when you look at the utility bills, natural gas consumption may be expressed in therms, not in cubic feet. In this case, either the emission factor must be converted or the activity data must be converted. Both are easy to do. 1 therm is equal to 100 cubic feet, so the emission factor should be configured to 12 pounds of CO2 per therm. Or, the number of therms combusted could be changed to cubic feet by multiplying the number by 100. Emission factors for fossil fuel combustion. Emission factors for fossil fuels are published by many government agencies. For example, in the US, the EPA, the Energy Information Administration, and the Department of Energy are all great sources for emission factors. Similarly, in the UK, the Department for Energy, Food and Rural Affairs, known as DEFRA, is the best source for emission factors. You'll find emission factors relevant to each country at that nation's appointed agency, which is typically an equivalent of an EPA or DOE. On an international level, the IPCC is an excellent source for emission factors. In fact, because the IPCC's mission is to provide guidance for national greenhouse gas inventories, it maintains useful information on calculating and applying emission factors from some of the more obscure emission sources, such as the cultivation of rice, certain types of smelting techniques, or the climate impact of reindeers and rabbits and other fur-bearing animals. Emission factors for electricity. Emission factors for electric consumption can vary greatly from one geographic location to another. This is because electricity is produced in a number of different ways, using different types of technologies, and using different types of fuels, some of which may have a higher carbon content than others. For instance, a power plant that runs solely on natural gas will have a much lower emission factor than one that runs on coal. That is because natural gas has about half the carbon content of coal for the same amount of energy. If that natural gas power plant also supplies heat, then the energy produced relative to the carbon emitted is even greater, and subsequently, the carbon intensity much lower. This diagram shows the average emission factor for electric generation in each of the 50 US states. As you can see, some parts of the country are much lower than other parts. This is due to the variation in power sources. Some areas of the country are heavily reliant on coal for power generation, while other areas have access to large amounts of hydroelectric resources. And some areas even generate substantial quantities of electricity from biomass and wind. Because of this variation, a company in Wyoming that consumes 1 megawatt-hour of electricity is responsible for more greenhouse gas emissions than a company in California that consumes the exact same amount. This is because Wyoming relies almost exclusively on coal, while California's emission factor benefits from a large amount of natural gas units and plenty of renewable energy. Similarly, if the company in Wyoming cuts its electricity consumption by 1 megawatt-hour, it would reduce greenhouse gas emissions into the atmosphere more than the company in California. As a result, it is important to use the emission factor associated with the exact grid or power pool that the facility is located in when creating a greenhouse gas inventory. And as utilities make alterations to their fuel mix and new power generation comes online, more and more renewables are also being deployed, so the electric emission factor changes from year to year. So, whether you are reporting consumption at a facility from a specific utility, or consumption of an entire organization on a national level, try to use the emission factor applicable for that reporting year. Take a moment to review your supplementary documents for examples and snapshots of the many relevant nationally and internationally useful emission factors.